says that if three sides of one triangle are equal to the three sides of another triangle, then the given two triangles are congruent. So let us see one example here. So as I have written here, side AB of triangle ABC is equal to QR of triangle PQR, BC is equal to PR, and AC is equal to PQ. Now if I compare, if I see the first and the second ones, if this vertex B is common, so we can say B corresponds to vertex R. Similarly, in the first and third one, A is common. So here if you see on the right hand side, first and third, Q is common. So A corresponds to Q. Like this you will write the correspondence. And obviously C is left out with P, right? So we can say the correspondence ABC to QRP is a congruence, or I can write it as triangle ABC is congruent to triangle QRP. So this is side, side, side. So this theorem is accepted without proof. Similarly, we have theorem number 7.5, which is RHS congruence rule. If in two right angle triangles, that means the triangles should be right angle triangle, the hypotenuse and one of the side of the triangle are equal to the hypotenuse and one of the side of another triangle, then the two triangles are congruent. So this is right angle. R stands for right angle, H for hypotenuse, and S for side. So let us take one example here also. Now you can see I have drawn two right angle triangle. Angle Q is right angle, and in triangle XYZ angle Y is right angle. If I say side PQ is equal to side YZ, and also hypotenuse PR is equal to hypotenuse XZ. So which correspondence will be a congruence? You can see first of all the right angles. So Q is with Y. Second, we have side PQ is equal to side YZ. Angle Q is equal to angle Y, side PQ is equal to side YZ. So this is one side, this is one right angle, and now the hypotenuse. PR, the hypotenuse, is equal to XZ. So we have RHS, that is right angle, hypotenuse, and side. So here you can see if Q is with Y, so obviously P is with Z. So we can say P is having the corresponding vertex as Z, and R is left out with the third one. So what is left here? X. So we can say here in this triangle, triangle PQR will be congruent to triangle ZYX. This is the way you will write the proper correspondence. And this theorem also doesn't have, we don't have to prove this theorem. Now let us see the first question, exercise 7.3. It's given triangle ABC and triangle DBC are isosceles triangles with the same base BC. So, and also it is given that A and D are on the same side of BC. That means suppose if I am drawing BC, this is side BC, okay, and A and D are on the same side. So suppose I have this as A and here somewhere as D. These two are isosceles triangles. So AB will be equal to AC. So AB is equal to AC. Similarly, in triangle BDC, so this is the second triangle, BDC is also isosceles. So we can say BD is equal to DC. Okay, we need to prove the following result. Before that, it is also given AD is extended to intersect BC at point C. Okay, so if I extend this AD, it will intersect BC at point P. So this point is P. So we will see the first result here. You need to prove triangle ABD and triangle ACD are congruent. So this is so simple. The above two triangles I will show you here. This was triangle ADB and this is triangle ADC. Okay, so it is quite obvious, it is given in the data AB and AC are equal. AD is a common line segment as well as BD and DC are also equal. So by SSS both the triangles will be congruent. So let us write down the steps. So you can see I have written in triangle ABD and a triangle ADC, AB and AC are equal, that is given. BD and DC are equal, that is also given, and AD is equal to AD, which is common. So by SSS rule, triangle ABD and triangle ADC are congruent, which was our first result. Okay, we have already proved the first result. Now what is the second result? We need to prove triangle ABP and triangle ACP are also congruent. So let us see in the figure which is triangle ABP. So this is ABP. So I'll just draw and show you. This is triangle A, B and P. The second figure is triangle A, C and P. So this is ACP. In this triangle also we know that AB and AC are equal. AP is the common line segment. So we have only two sides equal. We don't have the third side. It's not given BP and PC are equal. So how will we prove that these two triangles are congruent? So already we have proved in this result triangle ABD and triangle ADC are congruent. These two triangles are congruent. So by CPCT, can we say angle BAD will be equal to triangle DAC? So yes, which shows BAD is the same angle BAP, and so angle BAP is equal to angle CAP, and thus by side, angle side, these two triangles also will be congruent. So let us write up to that much. So you can see I have written by the previous result by CPCT angle BAD is equal to angle CAD, which is result number 1. Now in the given two triangles AB and AC are equal, that is given. This result can be written as in place of BAD I can write BAP, because D and P are on the same line segment. So this result is obtained by result number 1, and AD is the common line segment. So this is side, then angle, then side. Thus we can say that by SAS rule, triangle ABP is congruent to triangle ACP, right? So this is the second result what we have proved. Now let us come to the third result. Third result was you need to prove that AP is bisecting angle A as well as angle D. So I'll show you the figure again. It was like this. This was angle A, and here you were having A, then D, and then here on line segment BC you were having this point P. Okay, this is line segment BC. We need to prove that this ray AP is bisecting angle A and also it is bisecting angle D. Okay, so first of all let us see how it will bisect angle A. So already by angle BAD is equal to angle CAD, we can write by result number 1 as angle BAD is equal to angle CAD. This shows that line segment AD bisects angle A. So the first result is proved. Now we need to prove that it is bisecting angle D also. So let me tell you, as we have already proved in the first result that triangle ABD is congruent to triangle ACD. So by CPCT again, okay, we can say by corresponding parts of congruent triangles, can I say angle ADB and ADC also will be same? Yes, the angle ADB will be equal to angle ADC, right? Now you can see this ADB and BDP are forming linear pair. So we know that angle ADB plus angle BDP is forming 180 degree because they are actually linear pair of angles. Similarly, angle ADC plus angle CDP is also forming 180 degree as it is linear pair of angle. So these two angles are also forming 180 degree. As both the answers are same, we can equate angle ADB plus angle BDP is equal to angle ADC plus angle CDP. This shows, earlier we have already found ADB and ADC are equal. So if these two angles are equal, it will be cancelled, and so we got angle BDP. Angle BDP is equal to angle CDP, and if BDP is equal to CDP, which shows that this ray AP will divide angle D also into two equal parts. So finally I got AD bisects angle D. Okay, so these are the two results we have proved. AD bisects angle A and AD bisects angle D. So this is the way we have proved the third result. Now the last result is left. Last result is we need to prove that AP is perpendicular bisector of BC. Okay, so please see all of you. If I draw only two triangles, okay, suppose this is A, B, C. This is AP. We need to prove it is perpendicular as well as bisector. That means we need to prove these two angles are right angle, and also we need to prove that P is the midpoint of line segment BC. Now if you remember, we have already proved in result number 2 that triangle ABP is congruent to triangle ACP. And so by CPCT, corresponding parts of congruent triangles, can I say angle ABP and APC will be equal? So yes, angle APB will be equal to angle APC. First thing is this. Second thing, by CPCT, BP and CP also will be equal. So we got BP is equal to CP. So when BP and CP are equal, that means P is the midpoint of line segment BC. And here as APP, angle APP and angle APC are equal, we know these two are forming linear pair, so I can write angle APB plus angle APC is equal to 180 degree. You can write the reason because of linear pair of angle. So both are equal, we can write 2 times angle APB is equal to 180 degree, and so angle APB is equal to 180 upon 2, which is equal to 90 degree. So one side I have proved it is forming right angle, one side I have proved it is forming midpoint, and right angle and midpoint, so together it is been proved that AP is the perpendicular bisector of BC. So thus I have written AP is the perpendicular bisector of BC, and this result is also proved. Okay.